was asked to talk a little bit about the washing, about the decontamination phase. And I would like to just come back to the question that you referred and that my colleague Max has answered, that the washing is a critical step, providing you with the possibility for a quality sterilization. So let's look at it. So the challenges first. The topic of my talk will be the challenges and the regulations. So what shall we face and how are we guided through it with the help of modern standards? So according to World Health Organization, today, at any given time, 1.4 million are getting infection inside the hospitals. And this is the recorded infection, and how many of them are not? You as the healthcare professionals maybe have a better view into that. Then if you look at the global situation and the other global trends, is that the aging population is consuming more healthcare, so you have more to do. The growing middle class in some areas of the world uses more healthcare, so people like us have more to do. Certainly, the growing resistance against the microbes, against the antibiotics is on the agenda today. And what can we do other than use antibiotics? So these are the bigger challenges that are actual for us to start looking at. And then, for sure, there are the regulations. The first regulation that help us is the ISO 17664. This one is pointing at the instruments. So what are the critical steps that the instrument has to go through in order to be sterile? So today, in the next half of an hour, we will look at the preparation at the point of use by the side of the operational theater. We will look at the preparation, cleaning, and disinfection, hopefully inside the CSSD, and we will look at the drying. The other points my colleagues have already started covering or will cover during these 2 days. So what is the other challenge that we as infection control workers face while processing the instrument? This is surely the quality of the soil. So the blood and its quality. It coagulates quickly, it's sticky, it dries and creates a risk being dry, and it traps microorganisms under the surface. So these are some viruses probably trapped under the biofilm. This is exactly what Max mentioned before. So if it's not clean, it cannot be sterile. This is a good axiom to live by. The sterilizing agent has to have a chance to come in direct contact with the entire surface area of the instrument appointed at a given time at a given temperature. Okay? So, at the point of use, what do we do as step one? If we remember the guideline for the instruments, so the first one was the point of use. So what do we do there? We have various guidelines, some of them local, some of them international, and they recommend not let the instrument to get dry. And the time frame for that is 15 to 20 minutes. So how do healthcare professionals fight with this situation? In different countries, there are different things done. So, for example, in Italy and France, the instruments are soaked, they're placed into the detergent at the operational theater, and then they're transported down to CSSD. In, for example, Scandinavia, there is a small washing unit, there is a small washing machine by the side of operational theater, and they do a quick rinse cold water process before they send it down to CSSD. The spray or gel or foam can be applied on the top of the instruments to seal the moisture, or the instruments can be placed into plastic bags to seal the moisture, to keep it there before it gets transported to the CSSD. So let's have a look at the cleaning itself. So the first thing we talked about was the point of use. Now we are in a CSSD, and these are the things that have to happen if we want to have a quality cleaning. There has to be time, there has to be mechanical or chemical action, and there has to be exposure to the temperature. So the mechanical action can be reached through ultrasonic cavitation, through manual wiping or brushing, or through the flowing water through the spray arms in a mechanical disinfector. All right? Then there has to be a detergent. And there we have to be careful because we have to observe the instruments or the manufacturer's recommendations for the contact time and the temperature of the detergent. Luckily, most of the washers, they are calibrated to do this job for you, so you don't have to check it unless you do it once per month, for example. Okay? There has to be a water quality of a certain type to provide you with the possibility not to have a problem with the process, with the chemicals, with the machine. So these are the basic categorization of how you shall look at the water quality in your hospital. So reverse osmosis, you see, the last is the best, of course, for sure. So if you can do it, this is the best. And then we surely provide the water recommendation. By the installation, we give you a detailed recommendation looking like that. That will give you all the details you need to know what you have to meet water-wise. Then, coming back to the cleaning as a process, there has to be exposure to the temperature, and the most common temperature in the first phase, in the chemical wash, would be 45 degrees. It's quite common. So the best result is, according to us, is reached in the automatic washing machine. And for you, it's a reduced risk. It's reduced risk for operators, it's reduced risk for the patients. So then for sure, there is a capacity question, how much you can do during your day with the help of the quick machine. So there is the guideline 15883 that covers how the washer shall be working. So there are requirements as for design, for safety, as for the minimum cycle requirements, performance requirements, test methodologies. It's all covered and it's always ready for your reference. Most of you, I think, are very well familiar with that. So if we break down the process, what is happening in the washer disinfector, we already looked at the detergent wash, what was critical, the temperature, the time. Then there is a first rinse, and then there is a second phase, which is a thermal disinfection. And if you still reprocess something manually, this is virtually not possible to achieve in manual cleaning. So let's look at the second thermal disinfection phase. This is again an illustration of the washing process for you. We already spoke about the cold pre-wash, about the main wash, and now we are in a thermal disinfection phase. So pay attention that the temperature is over 90 degrees on the scale. Okay? So, and why do we have to do the thermal disinfection, the main phase? So, because the medical devices are classified in 3 categories. What is important is that we reach A0 value. This is a formula which expresses the level of lethality of microorganisms. And you can only have a chance to keep an eye if we are reaching it or no, and how, in an automated washer disinfector. So, have a look. To reach, this is a general table. So to reach 1200 level of A0, you have to expose for 1 minute at the temperature, expose an instrument for 1 minute at a temperature of 93 degrees. Okay, so let's have a look at the more detailed explanation here. So the non-critical instruments, for example, furniture, bed frames, a wheelchair here on the picture, has to require a level of 60, A0 60 is required, okay? And these are the semi-critical instruments. A value of 600 is required. And this is the example for you. The minutes of exposure and the temperature you have to reach to reduce. This is the example of how to process the semi-critical instruments. For example, the bedpan washer here. And then we go for the most important, for critical instruments. These are the ones that are in contact with blood, with the tissue, or potentially infected. And the minimum required value is 3,000. This is how you can reach it. At a 93 degrees for 2.5 minutes, for example. Or at a 90 degrees for 5 minutes. And this is the circle of a critical instrument and a CSSD. So, what do we use as a main guidance, norm-wise? Almost everything is covered by 15883. And you have a chapter for bedpan washers, for flusher disinfectors for them. You have the testing methods. This is always available for your reference. If you have further questions about the guidelines, you will be able to ask them a bit further. So the next question is what, on a practical level, if you have a washer disinfector, what could you do monthly or daily to make sure that you and your patients are safe? And I will not go into the whole procedure of IQ, PQ, of all the testing, initial or when you run the equipment already, but this is something which we suggest you could do quarterly or yearly, weekly or daily, if you have a washer disinfector. And I think you do, those of you who have it. So your service organization, our generous host, D&D Commerce, would be able to help you with the quarterly to yearly checks of, for example, water and chemical calibration, soil tests, which you probably also do yourselves, drying tests. This operation is called IQ-PQ, or validation, and it's important to have it. Then weekly, you can check the arms, the rotating arms in a washing machine, that they are not blocked and the water reaches the right pressure. And then daily, surely, we advise you use the wash monitors. The next possible question might be, can Steelco provide you with the solutions for that? And for sure we do. This is the product range, which we are extremely successful with. So we can provide you the full range of washer disinfectors from under-counter, from tabletops, to, this is the professional line, starting with 250-liter chamber for the 10-din containers, and finishing with a bed frame washer where you can roll the whole bed operational table into the machine. We have the basic capacity machine, and we surely do have the quick machines with the double chamber, smart tunnel, and this is a unique machine that gives you capacity like nobody else today in the world. It gives you 62 containers per hour. The first chamber only washing, the second chamber only drying. This we call a mini tunnel, and this would be the TW3000/2, a smart tunnel. This is one of the best-selling products we have the last 2 years. This is the capacity characteristics for you to understand what you can get out of this machine. So as you see, the last one is 62 trays per hour. So I think that would be it for the time being. Do you think you have questions about any of these points I touched? Because there is a big material behind each of it. We're good at the moment? Thank you very much. Thank you.